is Christy Varghese. I have trained more than 2 lakh aspirants for UPSC, CSAT also, and for other exams also. In the last 10 years, I have written few books on general aptitude section. So that is a short bio of me. There is a YouTube channel of mine called Christy's Classes, where also I provide classes for UPSC, CSAT. Okay, so now directly to civil service aptitude test. You all know, how many of you have attempted civil service exams before? Anyone? All of your first attempt, right? Okay, great. So, but you know that there is a section called CSAT, right? Yeah, I can understand the meaning of the laugh, mainly because last time also civil service aptitude test or CSAT was very tough. Compared to 2023, it was easier, but 2023 was the toughest question paper, and 2024 was almost of the same level, but not that much tough as 2023. And in aptitude or CSAT, there is 80 objective type question paper. All are objective type question paper. As all of you are writing for the first time, I'm just elaborating. Maybe you are already familiar, but still. So 80 objective type question paper, 4 answers will be there, and there will be, for each correct answer, 2.5 mark you will get, and for each wrong answer, you will lose 0.833 mark. And it's a qualifying in nature. The section is qualifying in nature. How much mark you score does not matter at all. You just have to qualify the paper. And for qualifying, how much mark you need? 66 marks out of 200. Out of 200, 66 marks, that is just 33%, right? All throughout your school or college, 33%, none of the tests were 33% qualifying. All the tests were 35% or 40% or 50%. So it is much easier, right? Yes? Okay. So 33% is the cutoff. That is fixed itself. That will not change at all. It is not according to difficulty level or according to number of people attempted. That will not change. It will always be 33%, 66 mark. In GS1, you don't know how much to target, right? But here you clearly know how much to target. Getting more than that also, there is nothing extra you will get. That will not be added to your merit at all. It is just clearing the 66 marks. But we cannot take a risk to target for 66 only, right? So we have to target for maybe 80 marks so that you can be sure that you will get 66 mark at least. Okay, so what are the 3 sections in UPSC CSAT? I hope all of you know that. Quant, reasoning, and comprehension. Quantitative aptitude means maths. Maths is the main thing, but maths and logic mixed. Reasoning means mainly logic itself, and comprehension means your comprehension skills. Some people interpret it as English skills, but it is not actually English skills. It is purely comprehension skills. But most of us writing exam in English. That is why we think that it is checking our English knowledge. That same question paper is available in Hindi also. But as only 2 languages are available for us, most of us prefer, all of you write exam in English, right? Or planning to write exam in English. So your basic English skills or vocabulary will help it definitely. But it is mainly to check your comprehension skills. Okay, and this is the syllabus of UPSC CSAT mentioned in the website. These are the topics in CSAT section. One is reading comprehension. That is what I told. Reading comprehension. Then interpersonal skills, including communication skills, logical reasoning and analytical ability, decision making and problem solving, general mental ability, basic numeracy, class 10 level. This is also again a myth. It is not class 10 level always. Sometimes, yeah, actually this was the main complaint of most students for last few years. That is why last exam they have avoided class 11 and class 12 questions. Class 11 and class 12 top questions are mainly this permutation combination. Last to last exam, 2023, many questions were there. 9 questions were there from permutation combination alone. But last time, questions were not there from permutation combination, mainly because in the syllabus it is mentioned class 10 level. Permutation combination we are learning in class 11 and 12. That does not mean next time they will not ask it, because for many years permutation combination are being asked. Just last exam it was not there, it was less number of questions. And data interpretation, that is graph analysis, bar graph, pie chart, etc. So that is a basic syllabus of UPSC CSAT, but this syllabus is very vague. We don't know which all areas to prepare for and all. That is why, as I told, simply speaking, quant, reasoning, and comprehension. These are the 3 areas. In this, my areas are quant and reasoning. Comprehension also I teach, but For you, I will be teaching quant only first. So the quantitative aptitude, the next almost 12 days, we will be discussing quantitative aptitude topics alone. Because this is the area that many people are afraid of, mainly because math we haven't learned properly. Na? That is why we think that quant is full of maths. It is not math. Math is a tool needed to do the questions. Only when it is needed, we have to use math. The problem is we unnecessarily use math. That is why we feel this section is very tough, right? So when it is needed, math should be used. But in many questions, math is not needed. It is more about how to eliminate options better, how to choose the right examples. I have devised 15 methods to solve questions of quantitative aptitude. There are 15 methods. 5 of them are elimination methods itself or rejection technique itself. A question you can do by selecting the correct answer also and rejecting the wrong options also. Many questions, if you are able to reject wrong options, that can give you faster answers. Okay, so about which all we will discuss in detail. So in 2024, this was the pattern: quant 40 questions, reasoning 13 questions. 2023 also, it is exactly same number itself, 40, 13, but that is not fixed at all. It is just a coincidence that last 2 years, the number of questions were equal. And the remaining 27 questions were from comprehension. But 2022, it was quant 35, reasoning 20. A person who is not good at math wishes that this reasoning section questions be more. But last 2 years, reasoning was very less, 13 questions only. 13 questions also, in that 13 questions, 2-3 questions are hybrid questions. Some quantitative aptitude elements are also there in that reasoning questions. Like it's a coding decoding question, but your good understanding of number system is needed to solve the question. Such questions were there last exam. Okay, so anyway, 2022, this was the trend. And if you want to see the last 12 years trend, this is the trend of questions. Reading comprehension, quantitative aptitude, and reasoning. These are the number of questions. And you can see that that is not fixed at all. The number keeps on changing. So, and in the notification also, it won't be mentioned that this time this will be the number, nothing like that. It is total 80 question. That is the only mention about CSAT section. So that is a basic intro. Clear any doubts regarding syllabus or anything else? Shall we start the topics? Because I'm allotted 35 hours for this quant and reasoning. Almost 19 to 20 topics we need to cover. So we have to go a little faster to cover all the topics. I don't want to skip any topic because you also may have a question to me like, which are the most important topics? Again, that is a very risky thing to do. Don't select topics. That is what I will suggest you. Because selecting topic was the biggest mistake many students did in the last few years. They will think that number system is very difficult for us. Let us skip it. And last 2 years, number system, too many questions were there. 2023, almost 24 questions were there. Last year also, almost 15 questions were there from number system alone. And permutation combination, for example, 2023, 9 to 10 questions were there. So students thought that we will totally devote on permutation combination alone. Last time questions were not there. That is why don't select topics. That is my suggestion. But towards like when last month preparation, we may be needing to select few topics for quick revision and all. But first learn all topics. After that, you can select or deselect according to how much you understood the topics. So before that, please don't choose topics. That is why I also want to complete all the topics. These are the quantitative aptitude topics. 19 to 20 topics are there. I will share the PDF, all these PDF, I will share it. And for each topics, I have selected one question for you to understand what all are the questions. Today, I'm not discussing that because that will take too much time. So in the slide, in the PDF, it will be there. You can refer it so that you get an idea. One example each for each of the questions. This is the reasoning topic, almost 11 topics. So for example, number system, classification of numbers is the first topic we are discussing today. So this is an example from 2023 question paper. And theory we will discuss today. Next topic is digits and place values. This is an example from 2023 paper. Then divisibility and remainder theorem. Divisibility and remainder theorem. This is an example. So this PDF I will share. You can go through it. And basic theory of each of the questions also I have mentioned it. So now we will directly go to the first topic. So I'm starting with number system mainly because last few years number system questions were more. So number system, I have divided into 6 different topics. First topic is classification of numbers. Yeah, I just want to know a few things from you. How many of you have learned maths till 11th till 12th class? Math. Okay. Most of you, right? Okay. And most of you have completed your degree, right? So in your degree, how many of you are humanities or commerce background? Or I'll make the question simple. How many of you fear math? Forget about degree. Okay, most of you, right? Okay. Then I just want to curate the class accordingly. That's why I'm asking. Okay, so classification of numbers. As most of you fear math, I'll start from the very base itself, right? Numbers. What all are the different types of numbers you know? Integers, then prime numbers, okay. Natural numbers. Okay, you know much more than what I thought. Okay, so don't worry. These basic understanding only is enough for understanding what I'm going to tell. Okay, so yeah, as I told, I will be using these 15 methods to solve questions. Each chapter, each questions, one of these 15 methods. Many of the questions need mathematical direct method. But the problem is we over depend on this single method only. For all questions, we know only this method. That is why we feel that every question is very time consuming. As much as possible, you have to avoid this method. But maybe almost 60 to 70% question, you cannot avoid it. But the remaining 30-40% questions, if you choose any other method, that will save a lot of time. And that will increase the number of questions you can attempt. You know, time is a big factor, right? 2 hours means 120 minutes. You have 80 questions to solve. But we are not going to target 80 questions. 40 to 50 questions is fine. 50 questions, say. So 50 questions, 120 minutes means how much time you will be getting. That's a tough math, right? Okay. Yeah, 2 to 2.5 minutes. 2 to 2.5 minutes on an average you should spend. But we will be getting, like, you will be getting trained such a way that you can do a question in 2 minutes. So what about the questions you cannot do in 2 minutes? That is the questions you should skip definitely. Out of 80 questions, UPSC didn't told you to do 80 questions. Unattempting question, there is no negative mark at all. If you attempt and get it wrong, then only you will get a negative mark. Okay, so avoiding the dependence on mathematical direct method, that is one thing we will be understanding throughout this lectures, right? For example, elimination. Elimination, again, many people know elimination by substitution. Just put the option into the question. But that will not work all the time. In few questions only that will work. In other questions, you have to do other elimination methods. Sometimes question into options is not, options into question will not work, but question into options will work. Or relating options will work. So about all these things we will be discussing. So yeah, as you people told, there are different types of numbers. These are the main types of numbers you have mentioned, but I haven't heard people telling about composite numbers. So I think I should discuss about it. Rational numbers. I'll just give a quick idea about all these numbers. What is natural numbers? Counting numbers, numbers which can be counted. Say I can say 1 person, 2nd person, 3rd person. For counting, I'm using the numbers 1, 2, 3, 4. 0 is not included there because for counting, I will not say 0 persons. 0 denotes nothing, but that is not part of counting numbers. That is not part of natural numbers. Why this is important? In question paper, you will be given among all the natural numbers. So you should not take 0 there. If you take 0 there, you will get a wrong answer. Among all non-negative numbers or non-negative integers. Non-negative integers means what numbers you have to consider? Positive numbers only? No, you should consider 0 also because 0 is also non-negative. It is not negative because there are 3 types of integers: positive, negative, and neutral integer. What is neutral integer? 0. So non-negative means positive and neutral. Non-positive means negative and neutral. So 0 should be considered in non-negative also, non-positive also. Keep that in mind. Okay, so natural numbers means counting numbers. To that counting number, if you're adding 0, that will make the whole number set. Whole numbers. 0, 1, 2, 3, 4 up to infinity. Then what about integers? 0 up to infinity, whole numbers is there. To that, you are adding negative integers also. Negative integers means negative of this counting numbers. Like I say, I took, like, I am borrowing money to, lending money to people. So I give 1,000 rupees or 2,000 rupees or 3,000 rupees, etc. to people. If I am lending money from someone else, for me, that is a minus 1,000 rupee. For example, I am lending 1,000 rupee. I'm just giving you an example how you can consider negative numbers in real life. If you are thinking like investment and return, or investment, if you are borrowing money, that is a negative investment, we can say. So that is an example of a negative number. Okay, anyway, -1, -2, -3 up to minus infinity are called integers. Sorry, they are negative integers. Minus, negative, positive, and neutral together will make the set of integers. So here, please understand, non-negative means 0 to infinity, all the numbers. Non-positive means 0 to minus infinity, all the numbers, right? Then what about rational numbers? What are rational numbers? Numbers which can be written in the form P by Q, where P and Q are integers, or simply speaking, fractions. Fractions are rational numbers. So tell me, 5 is a rational number? Is 5 a rational number? Yes, it is a rational number because 5 can be written as 5 divided by 1. Any integer is a rational number because any integer can be written as that integer divided by 1. Isn't it? So what is not a rational number? All numbers can be written as P by Q form. Na? Then why there is a term irrational? The prefix I means not rational. Na? So which is not rational? Root of -1, that is complex number. Root 3 or root 5. Root 3 can be written as root 3 by 1, but root 3 is not an integer. That is why that is not P by Q form, where P and Q are integers. Integers means these are integers. Na? So root 3, root 2, root 5, root 6, etc. are irrational numbers. Pi is an irrational number. You have heard about pi, na? What is the value of pi? 22 by 7. Accurately, it is 22 by 7. Na? Then that is P by Q form. Na? No, that is not the reason. 22 by 7 is clearly a rational number. Because I told you, any number which can be written as P by Q form, where P and Q are integers, are rationals. 22 is an integer. 7 is an integer. So 22 by 7 is clearly a rational number. Then why pi is irrational? 22 by 7 is rational. Pi is 22 by 7. Then pi should be rational. Na? First of all, pi is not 22 by 7. Yeah, many myth we had learned in school, we have to unlearn. Pi is not 22 by 7. Pi 22 by 7 is a rational approximation of the irrational number pi. Pi is an irrational number. 22 by 7, when you expand, you will get 3.1415 something. But exact value of pi is 3.1416, and it will never end. Here itself, it is error actually. That is why 22 by 7 is approximate value of pi only. That means all the area volume you learned in school was wrong actually. For example, radius is 7. Can you find the area of a circle? In geometry chapter, we will learn pi r square is the area of the circle. All of you remember, na? So find the area of a circle with radius equal to 7 centimeter. Find it. Yeah, find it with whatever understanding you have. We will put 22 by 7 into 7 square. 7 and 7 cancels. 22 into 7. When you multiply, you will get 154 centimeter square. We will make sure that we will put 2 lines under it to make sure that it is exactly correct, right? It is never exactly correct. It is 153.99 something. And in school, we have done it mistake itself. This equal to was wrong actually. It is not equal to, it is approximately equal to. All the formula where pi is involved, you cannot get correct answer. How much you try, you cannot get correct answer because pi can never end. Na? How many digits you write, it will be, still there is a small error in that. Are you getting the point? Because pi's exact value, you cannot find it at all. Find it means you have reached the end of the world because it is infinite number of digits. You cannot write infinite number of digits. Infinity is not a number at all. It's a concept only. Okay, anyway, are you getting the point? This was an approximate value. pi is 22/7 is approximately only correct. It is pi approximately equal to 22/7. There are better approximations of pi, 339/119 or something. You can Google it. That is much more accurate value than 22/7. Then why we are taking 22/7? Just for convenience, because 22 have only 2 digits, 7 have only 1 digit. Yeah, now all my life was a lie, right? Yeah, many of the things we learned in school was just for convenience. In calendar chapter, we learned what is a leap year. Yeah, February 29 is there. That is not a lie. Don't worry. February 29 is there. Then that year is a leap year. How to identify it? Every 4th year. Again, next mistake we learned in school. Every 4th year is not a leap year. Then by your logic, 2200 should be a leap year, na? 2200, because it's a multiple of 4. Every 4 year means multiple of 4. 2200 divided by 4, if you do, you will not get a reminder. That means it is exactly divisible. But it is not a leap year. 2200, 2300, 2100 is not a leap year, because there is a second criteria for leap year. That if the year is a century, it should be divisible by 400 also for it to be a leap year. Why? Okay. Don't worry, we will unlearn all these things, because these things are needed for your CSAT section. Because we think that 365 and quarter is an year. And do you think that much easy it was? Like Earth will decide that for humans' convenience, we will exactly revolve around the sun like 365 and quarter. No, it was never quarter. Just like pi 22/7 was an approximation, this quarter means 0.25. 0.25 was also an approximation. It is 365.2422 approximately, because there are digits following that. This 2422 considering as 25, that is an error, na? That is an error of almost 11 minutes. Every year we are making an error of 11 minutes. And this error, the calendar which had this error is called Julian calendar. We are not using Julian calendar. We have revised our Julian calendar to Gregorian calendar 400 years back. We still believe in Julian calendar, right? When you say that every 4 years there is a leap year, you are following Julian calendar. Julian calendar is not followed anywhere in the world now, but for religious purpose, many people consider Julian calendar still. But the international calendar we are using. When we say today is, yeah, I forgot the date. Today is July 15. That is July 15th in Gregorian calendar. In Julian calendar, it is almost 16 days before. Almost 16 days before. It is still June 30 or something. June 30 or June 29 maybe. That many days difference is there because of this approximation. So again, but in school, telling about this 2422 and approximation of values was very difficult, because the math teacher also cannot convince you math. Then how a social science teacher can tell you 2422 is approximated as 25. To rectify the error, there is a second criteria. So at that time, that was the truth we believed, because that was easy to learn. In most of the 4 years, there is a leap year. That is correct. But when it comes to century, it should be multiples of 400 also. Then only it can be a leap year. So that is a point that is needed in calendar chapter. In some questions, without this point, you cannot solve questions also. So then there I will teach about that in detail. So we were discussing about irrational number. Pi is an irrational number. 22/7 is just a rational approximation. That idea is needed in geometry chapter. When geometry, I'll teach more about pi and what all you should learn about pi. Anyway, pi is an irrational number. E is an irrational number. E is approximately 2.71, but that also it never ends. Okay, now I will give you one more justification why pi is irrational. Because when you write pi, you know that pi have 3.16 and it will never end. The digits will never end. Na? If it ends, we could write it as a rational number. For example, if it was 3.1, you can write it as 31/10. Na? That is a rational representation. Na? P by Q, where P and Q are integers. If it was 3.14, what you can write? 314 divided by 100. Na? If it was 3.141, that could have been written as 3141 divided by 1000. Na? But if it never ends, how many zeros you will put? Infinite number of zeros. Infinite number of zeros means that is not an integer. That is infinity. Division by infinity is not also possible. That is not infinity. Number of zeros is infinite number. That is not an integer anymore. Are you getting the point? That is why, that is one justification you can say why pi is irrational. Clear? Then what is prime number? Numbers which are divisible by 1 and that number only. Divisible by. Those numbers which are divisible by means factors. They are called factors. No? We'll discuss about factors also. This is also very important. Factors. What are factors? Again, try to learn the practical relevance of these things. Then you will get like more interest to learn math and quantitative aptitude. For example, I will ask you a very simple question. Circle, what number of, what is the angle around the center of a circle? 360 degree. Why 360 degree? Is it something like we have found it from somewhere? No, we just assumed it. We could have assumed it 100 also. 100 can be the central angle. 1000 can be the central angle. 10 can be the central angle. Then why 360? Because of this factors itself. Because 360 have a lot of factors compared to 100 or 1000. Number of factors of 100 is very less compared to 360. So if it is 360, we can divide the circle into smaller portions easily without making fractions. Because humans don't like fractions. From history, if you look at it, fractions are very difficult to understand. That is why we didn't want much fractions. If it is 360 degree, if you half it, you will get 180, 180 each. No? If you quarter it, you can again get 90, 90, 90, 90. If you divide it into 8 parts, you can get 45, 45, 45, 45, 8 parts. That means all the divisions are, those numbers are called factors. Dividing by 1 possible, dividing by 2. So 2 is a factor. Dividing by 3 is possible. 4 is possible. 6 is possible. 5 is also possible. Sorry. 5 is also possible. 6 is possible. 7 is not possible. 7 is not a factor. But being all numbers being factor, it is impossible anyway. 1 is the only such number. If you take 1 as the central angle, right from the first one itself, it is fraction only. Na? That is why 360 is taken as the central angle of a circle. It is just for convenience. There is no other reason at all. 360 can be divided into smaller fractions easier because 360 have more factors. These are called factors of, these are the factors of 360. That is why it is called highly composite number. That is not needed for CSAT. That is why skip that part. What is highly composite? Skip it. If time allows, I'll teach in another class. And factors, when you learn, try to, I'm telling the practical thing which help you in exam. Write factors in pairs itself. That is easy to understand. For example, 360, if you're trying to find factors. How to find the factors? There is a prime factorization method. I'll come to that when we discuss about LCM and HCF. 1 into 360 is 360. Na? That means 1 and 360 are factors. Or in pairs, we can say 1 and 360 are 2 factors. Then 2, if you take, there will be a counterpart for 2. Na? 2 into something is 360. That is why 2 is called a factor. Na? 2 into what is 360? 180. That means 2 and 180 are pairs. I have used this color code to make you understand. This red, that means these are pairs. 2 and 180. Similarly, 3. 3 into what is 360? 3 into 120 is 360. That means 3 and 120 are factors. 4 into 90 is 360. So 4 and 90 are factors. 5 and 72, factors. 6 and 60. Similarly, you can understand each of the pairs. And this understanding is needed for many questions to solve. So keep that in mind. I don't want you to mug up a lot of things. I want to practically understand things. So what is most important that I will tell you, those things you can note down. These flashcards, I have created almost 100 flashcards for this UPSC CSAT, which covers all topics of quant and reasoning. That in each of the chapter you will see in the PDF also, it will be available. So anyway, that are called factors. A number which have more than 2 factors are called composite numbers. Because by default, the number and 1 will be factors. Na? For example, 17. 1 into 17 is 17. That means 1 and 17 are by default factors. For all numbers, 1 and that number will be factors. No? All of you clear about that? So that means if only those two factors are there, those numbers are called prime numbers. 1 and that number only will be the factors of those numbers that are called prime numbers. So more about prime numbers, we will discuss it. So natural number is called prime number if it has exactly two positive factors, namely 1 and itself. Positive factors means negative factors are also possible, but for CSAT, you need only positive factors. So when we see factors, I'm only meaning about positive factors. Okay, so for example, 2, 3, 5, 7, 11, all these are prime numbers. These are the first 25 prime numbers, or these are the prime numbers below 100. These are the prime numbers below 100. All these have only two factors, 1 and that number only. For example, 19. 1 into 19 is 19. There is no other way you can write it as product of two natural numbers. That means there is no other factors. That is all clear now. And some properties of prime numbers, let me clarify. Some people, the mistake they make is they consider 1 as a prime, 1 is not a prime, 1 is not prime also, 1 is not composite also. Normally a number which is not prime is called composite number. But 1 is neither prime nor composite. Keep that in mind. So because 1 have factors, 1 and that number is 1 itself. So 1 does not have two factors. It has only one factor. Prime number should have exactly two factors. That is why it is not a prime actually. So anyway, so the smallest prime is 2. That all of you know now. And 2 have the speciality that it is a only even prime. This property is very important. In 2024 also there was a question which needed this property. 2 is the only even prime. Because even all of you know what is even number, na? Even number by default have two factors. Sorry, by default have 2 as one of the factor. 2 into something, that kind of numbers are called even number, na? So that is why normally even number should have more than 2 factors, because 1 and that number and at least 2 is a factor. At least 2 is a factor. For example, 4. 1 into 4 is 4 and 2 into 2 is also 4. That means 1, 4 and 2, there are 3 factors. So every even number have 2 as an extra factor other than 1 and that number. So definitely every even number should be composite number. But 2 is the only even number which is an exception. Because 2's factors are 1 and 2 only. That 2 is that number itself. No? So there is not a third factor. So that is why this property keep in mind. And 1 is neither prime nor composite, you learn. These two properties are just like fun facts that is not needed for exam. But every prime number can be written as a multiple of 6 plus 1 or multiple of 6 minus 1. For example, look at this. Every prime number greater than 3. 5 can be written as 6 minus 1. Na? 7 can be written as 6 plus 1. Multiple of 6 plus 1 or multiple of 6 minus 1. 11 can be written as 12 minus 1. 12 is multiple of 6. Na? Minus 1. 13 is what? Multiple of 6 plus 1. 17 is what? 18 minus 1. Multiple of 6 minus 1. 19 is what? Multiple of 6 plus 1. Every prime number above 3 can be written like this. But that will not help you much because every prime number greater than 3 can be written like this. But that does not mean every multiple of 6 plus 1 or multiple of 6 minus 1 is prime number. The converse may not be true. That is called converse, means the reverse of it. P implies Q means reverse is Q implies P. For example, 25. 25 is 24 plus 1. Na? But still it is not a prime number. That's why I told you these two properties will not help you to solve question. But as a interesting fact about prime number, you can keep it in mind. And how to check prime number, this when question arises, I will teach you, or you can go through this flashcard to check whether a number is prime or not. Okay, so I will recommend you to learn at least few of the first prime numbers, because in exam time, checking each of the numbers and finding it will be difficult. Yeah, up to 30, I think you already have an idea. This is prime or this is not prime. No? Up to 50 at least try to learn. Best case, if you can learn up to 100, very good, but that is too many numbers. At least 50 up to try to learn it. So that is prime number. Then a number which is not prime is normally called a composite number. Then even number, odd number, all of you know. Na? Now another misconception about even number, odd number is Many people believe that even number starts from 0 or 2. That is totally wrong. Even number never starts or never ends because it starts from minus infinity to plus infinity. That means minus infinity is not a number. So you cannot say there is a start because negative numbers can also be even. Please understand that even number does not mean positive number or whole numbers only. Minus 2, minus 4, minus 6, minus 8, all are even numbers. Even numbers, okay. I will summarize this and then go to the next thing. So even number is multiple of 2 kind of number, na? 2 into something. You should be able to write it as 2 into something. 2 into a negative number also is fine. Then what is odd number? 2 into something plus 1 or 2 into something minus 1. Likewise, you should be able to write. For example, 7. It is 6 plus 1 or 8 minus 1. So it is multiple of 2 plus 1 kind of number or multiple of 2 minus 1 kind of number. Now, all these numbers or majority of these numbers, you can understand using chairs. So this is one analogy I teach students. Using chairs, you can understand numbers properly. Then you will never forget about numbers and it will be easy to do many calculation also using this idea. I'll give you a brief idea. What does that mean? So what is even number? For example, in this class, the chairs are not like each row have same number. But think that you are getting into a room and in that room, chairs are put such a way that there are 20 rows are there and every row have 2 chairs each. That means the chairs are in multiples of 2. That means clearly that's an even number. Na? I'll tell you why this analogy will help you to calculate better. So even numbers, if you think in terms of chairs, that should be a rectangle where 2 row or 2 column should be there. I'm considering this as a rectangle. 2 into 4 rectangle. Na? This is 2 into 4 rectangle, we can say. But odd number, how much you try, how much you rearrange, you can never make it into a rectangle with 2 rows. Either one chair will be extra or one chair will be less. For example, in this case, here one chair is missing, or we can say one chair is extra. That means this much is a rectangle, 2 into n plus 1 we can say. Or if you consider it as a rectangle of 5 columns and 2 rows, one chair is missing. That means mathematically speaking, 2n minus 1. 2n plus 1 or 2n minus 1. This chair is missing. Are you getting the idea? This idea will help you to understand the arithmetic of odd number and even number. For example, if you want to learn odd number plus odd number, what is it? This is a most important thing needed for CSAT. Almost 5 previous year questions was based only on this. Even 2024, 2 questions were based on this. Odd number plus odd number is what? Odd number into odd number is what? Even number into even number is what? So to understand that, this chair analogy will help you. Keep this picture in your mind. To this odd number, if you add an odd number, what will happen? This extra chair and the extra chair of that second number will add up to make it a rectangle. Na? Are you getting the point? That means odd number plus odd number will be odd number only. Sorry, even number only. What about even number plus odd number? This plus this. Odd number, because this chair will be extra. Na? Getting the point? 2n plus 2n plus 1. It will definitely be odd number. You don't have to take examples for that. You can just understand from this. What about even plus even? Even only, because this chair, it is a rectangle. To that, you are just adding one more rectangle. So it will be even only. Then what else? Yeah, even plus odd plus even, both are same only. Addition is commutative. A plus B, B plus A means the same. About multiplication also, you can understand the same way. For example, odd into odd, you want to understand. What is multiplication, first of all? It is repeated addition. Na? For example, when we are saying 5 into 3, 5 plus 5 plus 5, that is 5 into 3. Na? That means it is repeated addition. So this is say 9 chairs. Na? So 9 into 3, we want to know whether it is there. The values are easy, that, but in exam hall, taking this value sometimes will be time consuming. If you have this idea in your mind that odd into odd is always odd, that will help you to solve questions faster. Because there will be at least 5 or 6 cases you have to do in a single question. Odd into even into odd, then that raised to 2 or raised to 5. I'll show you questions of 2024 itself of the same type. So anyway, for example, if it is 9 into 3, what happens? That means 9 plus 9 plus 9. That 9 and 9 added you will get even number. Na? This plus this will match to make a rectangle. To that even number, you are adding again an odd number. Na? That will be odd number for sure. Are you getting the idea? Same way you can think about even into even. Even into even means, for example, this 8 plus 8 plus 8 plus 8. That if you are multiplying even into even also, even to odd also, it will be even only. Because rectangle, 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 rectangle. Any number of times if you put, you will get rectangle only. Na? Getting the point? That means what is a mathematical property we learned? In a product, if there is one even number also, that product will always be even. Whatever be the other number. Even into odd is also even into even is also even. This property will help you to solve questions. So keep a note of, take a note of it or remember it. Finally, yeah, even into odd, even into even we learned. Odd into even. Odd into even will be even because I told you already. Na? Odd into even into odd, both are same. Na? So that summarizes all the arithmetic of odd and even. So in this flashcard, I have written these facts. Odd plus even plus even. What is there for addition? Same thing as subtraction, because subtraction is nothing but negative addition. So the rules of addition is same for subtraction also. You don't have to learn it separately. So that is clear, no? And multiplication, I told you, if there is one even number also, the product is even. For the product to be odd, the only way is both should be odd. Both should be odd. And multiplication rule is applicable to even to an extent only. Sorry, for division to an extent only. It is not exactly same rules. First of all, for division, first criteria is it should be exactly divisible. Without being exactly divisible, you cannot say it is even or odd. Na? For example, 10 by 3. 10 by 3, is it odd or even? It is not odd, not even, because you are not able to divide it properly. Na? That is why, first of all, it should be exactly divisible. If it is exactly divisible, then odd by odd is always odd. Odd by odd is always odd. For example, 9 by 3. 9 by 3 is 3, na? Odd only. 27 by 3, odd only. Even by odd always will be even. Because even number is 2 into something. That 2 will always be there itself, na? When you cancel also. Because odd number does not have a 2 in it. This odd and other than 2, other numbers only can be cancelled. So 2 will there definitely be there. Again, that also true only if it is divisible. If it is not divisible, the question does not arise whether it is even or odd. And even by even, this can be even also, odd also. For example, 10 by 2 is 5, na? Even by even. But 20 by 2 is 10, even. 10 by 2 is odd, 20 by 2 is even. Are you getting the point? Division you can understand with chairs, but it is little complicated. That is why taking examples can help you understand. So, and what about powers? These are called exponents. A separate lecture on exponents will be there. But anyway, odd number raised to any number will always be odd. Why? Because exponents is what? Repeated multiplication. Na? 3 raised to 5 means what? 3 into 3 into 3 into 3 into 3. 3 into 3 is odd, na? Again into 3 is odd, because odd into odd is always odd. This odd into odd is always odd. This is enough to say that odd number raised to any number will be always odd. Same in the case of even raised to any number. What is, say, 2 raised to 5? 2 into 2 into 2 into 2 into 2. 2 into 2, even. That into again 2, again 2, again 2, that will always give you even only. Na? Understand the logic and learn. Don't by heart. Clear? All these things. This was asked maximum number of times from number system. Just this odd number, even number, arithmetic, whether you know properly or not. So you should practice this because it can give you marks. Even in 2024, it was there. Okay, I have told a lot of theory, but without application of theory. Okay, let me complete that chair analogy. Otherwise, I will forget about it later. So even number, odd number, how to understand with chairs, you understood now. What about composite number? Can you represent what we can say about chairs of composite number? For example, when you get into a room, you have 20 chairs. What all way you can properly arrange it? You can first put, say, 4 chairs in every row. Likewise, 5 rows are possible. Na? That means 4 and 5 are called factors, right? that row number and column number are called factors of the number 20. You can arrange it like 10 rows, 2 chairs each. That is 10 into 2 is 20. That 10 and 2 are factors. What other way you can arrange? If you want, you can put all 20 chairs like a queue. 1 row of 20 chairs or 20 rows of 1 chairs each. Are you getting the point? That means 1 and 20 are also factors. That means if you can write a composite number, you can form a rectangle in such a way that it have more than 1 row or more than 1 column. Sorry, it is more than 1 row and more than 1 column itself. If it is prime number, you can write it only as 1 row rectangle or 1 column rectangle. For example, this is 7 chairs. 7 chairs, there is only one way to put it. Either 1 row 7 chairs or 1 column 7 chairs. Both are identical only, vertically or horizontally. So prime numbers can be written, if you are making rectangles of prime number, that will always have 1 row only or 1 column only. But composite numbers have more than 1 row, 1 column. That way you can understand a composite number and prime number also in a practical way. Okay, now with questions, we will discuss more and then go to other theory. So any more doubts about what is natural number? I have given proper definition in your PDF. It will be there. You can read it in case you have doubt on any of these numbers. Integers, as I told in exam, you can see sentences like this: among all positive integers, among all negative integers, among all non-negative integers. There you should be clear about what it means. Okay, then yeah, this number line idea is also important when we say about integers or rationals. This number line idea, what is number line? Yeah, the numbers are just distributed in a line. This idea will help you to compare numbers. For example, -4 and -5, which is bigger? Numbers to the right of the number line is bigger than the left. So definitely -4 is bigger than -5. Yeah, when question comes, I'll show you how number line can help you. So all these are school maths. I haven't taught anything extra than school math, but some of our understanding about school math, I just tried to redefine it so that there is no confusion. And this formula is needed. Again, with questions, I will tell you which all formula to by heart or which all formula to understand. What is rational we learned? Yeah, when we discuss about rationals, another way you can tell it is fractions. Fractions, there are different types of fractions. That also you should know. One is proper fraction. What is a proper fraction? The numerator is less than or equal to the denominator. Numerator means number on the top. P by Q. P is called numerator. Q is called denominator. If the numerator is less than or equal to the denominator, that is called proper fraction. 1 by 2, 2 by 3, 19 by 20, etc. Improper fraction means numerator bigger than denominator. P by Q form, P is bigger than Q. P is bigger than Q, that is called improper fraction. Then what is mixed fraction? Mixed fraction just means improper fraction written as a proper fraction. For example, when you get 1 mark for a question and half mark for the next question, total how much marks you got? 1.5. 1.5 means what? 1 into half? No, it is 1 plus half. 1 plus half, we represent it as 1.5. That is just a notation. That plus we don't want to write all the time, because in numbers, when you write plus, it will be confusing. That is why we have defined a notation that x plus p by q means x and p by q. X and p by q. So that is called mixed fraction. So what is the corresponding improper fraction of it? What is the improper fraction of 1.5? 1 into 2 plus 1, right? Divided by 2. Or simply speaking, 1.5 means what number divided by half means 2. 1 by 2. What number divided by 2 will give you 1.5? 3. 3 mangoes, if you divide equally among 2 people, everyone will get 1.5 mango. 1.5 mango. That 3 by 2 is called improper fraction. 1.5 is called mixed fraction. Both means the same. 3 by 2 mangoes and 1.5 mangoes means the same. 3 mango divided among 2 people. Everyone will get 1.5 mangoes. So writing it as 3 by 2 is called improper fraction. Writing it as 1.5 is called mixed fraction. So you should know how to convert mixed fraction to improper fraction. And if you want, this is a step-by-step process, but I will totally say, don't do this. This is how we learned in school. If there is no other way, follow this. But you can actually, if you understand numbers properly, these steps are irrelevant. These steps are waste of time actually. For example, in the case of 3 by 2, how to write 3 by 2? You just think about it. 3 mangoes, I want to divide among 2 people. First, what I will do, the 2 mangoes I will divide among 2 people, because that is possible to divide. Na? So everyone will get 1 mango. No? The remaining 1 mango I cannot divide. So what I will say, I can say it is half I can give. Na? I cannot divide it into natural number, but I can divide it into fractions as half. The same idea is enough for bigger numbers also. For example, say 30 by 7. 30 by 7, when you see 30 by 7, don't think it like numbers. Think it like ideas, like 30 mangoes are there. I have 7 people to divide it among. First, I will do what? 7 mangoes, 7 people, 1 mango each. 14 mango, 7 people, 2 mango each. 21 mango, 3 mango. 3 mango each everyone will get. If it was 28 mango, 4 mango each. That means 28 mango I could have divided. Remaining 2 mangoes I cannot divide. So don't do it. Write 2 out of 7. Because 2 mangoes divided among 7 people, everyone will get 2 by 7 of the mango. This is called mixed fraction. Na? When you do this process also, you are going to get the same thing. But why overcomplicate things? Are you getting the point? Yes? Correct. Mathematically speaking, that is correct. But what I am saying is that is not needed. Numerator, denominators, forget about all that. Try to understand practically what does this mean. I have 30 things to divide among 7 people. Again, I know that this is going to be difficult to relearn this. Because in school, we have understood that we should have a protocol that this is the process. I should not deviate from that. I will just by heart that now. Including me, I have done this. But I took a lot of time to relearn this. But relearning was worth it. That is what I'm trying to say. If for the next 12 days, if you just follow what I'm saying, that what some of the things you learned in school, you have to relearn it. Definitely our brain does not want changes. Our brain will have this law of inertia working. Unless an external force is applied, our brain will not change. Our brain will say, we have a method, why change it? Even if it takes time, even if after exam we say that was full of math, that was time consuming, our brain will still say, this is a habit we developed, don't change it. So you have to force yourself to change it. Then only you can see math in a different way, see quantitative aptitude questions in a different way. That is why in many cases, I don't know how many of you realized it, for each of the thing, I tried to connect it with something that is in real life or something that is more practical to understand than mathematical. Math is a tool that should be used only when it is needed. I will give in PDF all the mathematical ways also, because I don't want to take a risk that you should not say that I didn't taught you this. But I will say, don't do this. This is not the proper way. This is the proper way. But if you're not at all able to do this, you have to depend on this, because some way or the other, we should solve the questions. Na? But how much you can shift from here to here, that much more questions you will be able to do, because you will be able to save time. That is a reason. When you are logically thinking, you will save a lot of time. In questions, you will understand this better. So, okay, anyway, is this much clear? Okay, so that is about rationals and fractions. Some of the fractions, if you know the percentage of it, this I will discuss more in the percentage chapter, percentages and fractions. There will be 2 topics that we'll be discussing. That time I will teach more about this. So what is irrational we discussed already. What is prime number we discussed. Facts about prime number we discussed. Perfect squares, again, questions were not asked. What is perfect square? All of you know, na? Square of a natural number is called a perfect square. 36 is a perfect square because it can be written as 6 square. But 35 is not a perfect square because the square root of 35 is 5.9 something. That is a fraction. Na? That is not a natural number. So, yeah, perfect square, the chair analogy or stone analogy, we can say the row number and column number of that rectangle will be equal, or we can say you can form a square from that. If the chairs are 36 chairs, you can make it like arranged it into 6 rows of 6 chairs each. Now, are you getting the point? So those kinds of numbers are called perfect squares. Okay, so factors, multiples, the terms are clear. Now, what is a factor? What is a multiple? For example, 30 is a multiple of 6. 6 is a factor of 30. These two terms, you should not get confused. That is why I'm defining. And this identities you need when question arises, we'll discuss more about it. Okay, now we should start questions. Otherwise, theory, math theory, there is no end to it. There is like lot of theory, but what is relevant for exam only, I have told you. So now we will see questions and learn more theory and more practical understandings. So classification of numbers, let us start with the 2024 question itself. In your worksheet, I think this is the first question. Yeah, question number 1. Question number 1. Try it. Yeah, I didn't knew that there was an online batch. Online batch students, was it all clear? If there is any doubt, please mention it in the chat. I thought that only recorded batch was there. So the live students, please respond. All the things we discussed is clear now. And you got the worksheet. Now. Worksheet, try the first question in your worksheet. Or look at the screen and try. So the arithmetic of odd number and even number I taught now. That is the only thing needed to solve this question. But how much you are understanding that arithmetic, that will help you to do this question faster. Even if you don't by heart it, you can still do it. But if you have that practical understanding, when I said that in a product, if there is an even number, the product will always be even. That will help you to answer this question much faster. Keep that point in mind and try this. Yes. B. Let's check. Any other answers? Yeah, you can tell aloud. When you get an answer, you can tell it aloud. Then only I will understand how much. Okay, I will put a timer also so that I get an idea how much time you're taking and you get an idea. Each question, 2 minutes I will give you so that we should have a proper learning, like how much time we are taking for each question. How many of you completed? Done. What's the answer? D. Any other answers? All of you completed. B is the answer. D also. Okay. Any other answers? Feel free to tell the answer. Let it be wrong. That is totally okay. We are learning now. I'm not assuming that all of you are experts in maths and quant. You fear math, na? So I only consider that way only. So I will not judge you or anything. A option. Okay. So I will take a poll. A option, how many of you got? B option, how many of you got? C option, how many of you got? D option. Okay. Majority of you got A option now. Okay, let's see. Shall I explain or shall I wait? Yeah. So let PQRS be distinct positive integers. Distinct positive integers. So 1, 2, 3, 4 up to infinity. Distinct means they should be different. Same numbers should not be. Let PQ be odd. It is clearly mentioned that PQ is odd. And RS is even. RS is even. So instead of P, I can put odd. Here also odd. Square. QS. Q is odd. S is even. That itself finishes the question. Na? I told you in a product, if there is an even number, that will be even for sure, whatever be the second number or other numbers. This S is even. Even into odd is even. That even into anything here, that will be even for sure. Na? That is enough to say this is correct. Don't waste your time on any other analysis. Don't take examples. This is not a question to do taking example method. This is a question to be done with direct method. So is it clear, all of you? Done. Next one. Can you do the same thing here? This is a number, this is a number, this is a number. Consider that way. Any of those numbers is even means it is easy to tell. Na? Any number even? S is even. S is even. Even into whatever this, that is not our concern at all. Even into something will only be even. Even into something is only is even. So this is clearly correct. Na? All of you? Done? Third one, Q plus R the whole square, Q plus S. So here there is no individual terms like S or Q or something to decide that it is even. So first you have to understand whether Q plus S is even or Q plus R the whole square is even. Then only we can say the product is even. So here we have to, the first two were super easy if you know the properties of even and odd. Third one, we have to substitute. Let us substitute it here. So question says that PQRS, PQ is odd and R and S is even. So I just substituted it here. Odd plus even the whole square, odd plus even. That product, what it is. First of all, odd plus even is what? Chair analogy. Even rectangle plus not a rectangle will not give you a rectangle. You will get an odd number only. So clearly this is odd. What about this? Odd plus even. Odd only. Square. Odd into odd into odd. Sorry, odd into odd. It will be odd only. Na? So that is odd. Product. If there is no even number, product can never be even. So it is odd into odd. Odd. Na? So this is correct. Very less people got option D. Na? Most of you got A, B, C. Is it all clear? What was the confusion? Can you tell me? Let us understand where we are going wrong, because that will help us in further question also. Third one, I think. Yes. Shall I repeat? Okay. Should I repeat any part? Any lack of clarity is there? Again, okay. If you want, yeah, basically this much only you need. Subtraction, addition, whatever rules, that is for subtraction. So, and division is not very much important. Multiplication and addition is most important. So look at it. Simply speaking, in the product, if there is an even number, that is enough to say that product will be even. Whatever be the other number does not matter at all. Odd into even is also even. Even into even is also even. And even into odd, odd into even, both means the same. That means, simply speaking, if two numbers are multiplied, one of the number being even is enough to say that product is even. Second number, let it be odd, let it be even, does not matter at all. And if none of the number is even, what will happen? Both are odd, then product is also odd. Is it clear? So that is how to understand. This much was enough to finish that question super fast. About sum, this is the idea. And that idea can be understood easily with that chair idea. Not rectangle added will be rectangle. That way you understand. Rectangle plus not rectangle will not be a rectangle. It will be not a rectangle. Rectangle will be a rectangle. When I'm saying rectangle, are you understanding? The chairs I'm saying about. Okay. And powers, whatever is the product idea, that only is power also. That is not something new. And this idea of even and odd was asked many times actually. So we will see similar questions together. That will be better. That will be faster also. 2024, from classification of numbers itself, almost 6 questions were there. 6 questions. Okay, try this question. That is question number. In this worksheet, I have given in year-wise order, but I will be discussing topic by topic, subtopic by subtopic. Together we will be discussing. This is question number 5 in your worksheet. Question 5 you can do, then question 6 you can do. They are similar, 5 and 6. Please do 5 and 6. 4 you can do as homework. That is similar type itself. but little time consuming question. 4 is homework, 5 and 6 you can try now. Any answers? D. Fifth one D, na? Okay, we'll discuss fifth one then. Consider the following in respect of prime number P and composite number C. So what is prime, what is composite, you should know. So prime number generally, yeah, that is where the properties of prime can help you. Prime numbers generally are odd number except 2. But 2, question didn't say avoid 2, na? So you cannot discard 2. 2 is also a possibility. Keep that in mind. But composite number can be even only or can be odd only. Even only? No. 9 is a composite number which is odd, na? So that can also be odd or even. So that is a problem here. That means when we say prime number, it can be even or odd. When it is composite number, it can also be even or odd. So you have to consider all those cases. When it is prime, don't consider only odd number. It can be even number too. Only one even number, but that is enough to make it possible. Okay. So keeping that in mind, P plus C divided by P minus C. So just using odd and even, you cannot solve the question. You have to check. So this division is even. This division is even. Yeah, you can look into that flashcard if you want. There actually I have taken even number division. Even you can get not only by one case. There are 2 cases possible to get even. So that is why from that, here you can take examples. Taking example will be easier. Because here generalizing is not possible because prime number itself have 2 variants. Odd prime, even prime. Composite number also have 2 variants. Even prime, odd prime. Odd, even composite and odd composite. Now, the keywords are very important. Can be means what? Is it possible in any of the case? Any of the case. In one case, if it is true also, it's fine. So our objective is to get one example which satisfies. If the word is should be means one example is not enough. One example is enough to contradict it, but to prove it, one example is not enough. But here one example is enough because the word is can be. Is it possible in at least one case? So create one case, that is the question. So for example, if I am creating prime number 2 plus 9, 2 plus 9 and 2 minus 9. Okay, that cannot be divided. So that example is not correct. Because in the case of division, I told you, right, it should be divisible first of all. It should be divisible first of all. So I will take 11. We have to trial and error. That is the only way. We have to trial and error. 11 and 9 we will try. 11 plus 9 is 20. Na? What is 11 minus 9? 11 minus 9 is 2. 20 by 2 is what? 10. Is it even? Yes, it is working. Try 2-3 examples. And after 2-3 examples, you get an idea it will be even or it will not be even. So, all of you understood? It is not even always. It can be odd also. But even is a possibility. So, 11 and 9. Then 11 plus 9 is 20. 11 minus 9 is 2. So, 20 by 2 is even number. Clear? Yeah.
Assuming the value of P and C, if you have assumed some value for question number 1, whether it be even or not, do we have to continue with that value?
No. It is not necessary. For each of the statement, you can take any value because the word is can be. Can be means any values for any set you can take. No problem. So here 2P plus C. Let us try with this example if it is working. If it is not working, you can take other examples. That's the idea. We can mix it up any way we want. There is no problem at all. So 2 into prime number 11. 2 into something is always even. Na? This is anyway. Here actually you can use odd number, even number property. Because I told you even into something will always be even. 2 into something is even into something. So it is always even. So whatever be the value of prime will not matter here because it is 2 into even into something. So this product is confirmed even. Even plus composite, can it be odd? Even plus what is odd? Even plus odd is odd. Na? So taking a composite number example for, odd number example for the C value is enough. Na? There are many odd composite numbers. Na? 9 is an odd composite number. So 15 is possible. Any odd composite number is fine. 25 is possible. So the same example 11 and 9 is also working. Any other example also working. Only condition is the C should be odd number. Whatever P you take, no problem here because 2 into P will make it even. Even plus odd is always odd. Here the property of even and odd helps for the second statement. For the first statement, example was important. Second statement, example and general idea about odd and even helps. What about the third one? P into C. Yeah, here also even into odd, odd into even condition will help. P into C, can it be odd? When will be a product odd? Odd into odd is the only way odd can be created. Na? Odd into odd. That means P should be also odd. C should also be odd. Can you take that? Yes. Prime number, many odd numbers are there. Composite numbers also, enough odd numbers are there. 11 and 9 itself will work. 11 into 9. Or any other 13 into 15. Odd, na? Is it clear, all of you? So what is the answer? D, 1, 2, and 3. So in the notes, I have added this. In PDF, you will be getting this. Writing down notes, my perspective, it is not very important. Practicing more questions is important. But if you think that in future, you will forget it and want to revise it, PDF is still there. If you are okay with digital things, that is fine. But some people get a satisfaction while writing. And some people believe while writing, we will learn more. If you feel so, and if it is effective for you, definitely you can write it down. That's totally up to you. But my perspective is first preference to do more questions. If you have time to do questions and write notes, do it. But if you have to choose among this, doing more questions is more important than writing down notes. To help you out, I am creating PDF solutions for you so that writing down notes, only if it helps you, do it. Otherwise, prefer this PDF itself. Clear? Completely clear? So the next question you can do almost the same way itself. Yeah, any answers? Sixth question, did you try? The sixth question, I think I forgot to add in the PDF. Okay, sixth question, what's the answer? D. How many of you got D? I'll just tell you the pointers, how you can do it. Same thing itself, P is prime and Q is composite. P into Q, can it be odd? We already discussed now. In the previous question, third point was the first point in this. Instead of P into C, here it is P into Q, same thing itself. Because 11 into 9, it is odd. So first statement is correct. What about Q by P? That is a new thing, na? Division. Q by P can be a prime. First of all, division means it should be exactly divisible. So 15, Q should be composite number. Now 15. 10 by 2, but Q, yeah, 10 by 2 is also fine. Very good example. 10 by 2. 10 is composite number, 2 is prime number. 10 by 2, 5 is prime number. Na? So that division, trial and error. There you have to do trial and error. P plus Q is prime number. Yeah, there you can take the help of the general idea of composite and, sorry, even and odd. P plus Q being prime number, prime numbers generally are odd except 2. The sum being prime number means 2 being prime number, 1 plus 1 is 2. So you don't want 2. You want the sum to be something else. That means you want an odd sum. Na? How you get an odd sum? Both being odd will not work. 1 even and 1 odd will help. Na? 1 even and 1 odd. 1 even, 1 odd, it is totally possible. Na? Take prime P to be 2. Then Q can be an odd composite number. 9, 2 plus 9. Or the other way around. If you are taking odd prime, 5, take an even composite. Odd prime, even composite. Even prime, odd composite. Are you understanding the point? This is how you have to generalize it. This generalization is only possible if you are getting into the topic. Just a peripheral knowledge of by heart knowledge is not enough. That is why I am trying to tell you, practically understand it. The chair analogy or stone analogy and all is told just for that purpose. Clear? Now how to do these kinds of questions? Look at the number of questions, about 5 questions on the same type itself. First question, fourth question, fifth question, sixth question, all are of the same type. And even in data sufficiency, you are familiar, na? Data sufficiency question. That is not a different topic. That's a type of question which can be asked in any topic. Data sufficiency means a question will be there. You have to answer. You don't have to answer the question. Question will be asked. To answer the question, which of these statements are necessary? 2 statements generally will be given. First and second both are needed, or first only is needed, or second only is needed, or both are not enough to solve. So that is the structure of data sufficiency. Last few years, data sufficiency questions are more. In 2024, all chapters together, almost 12 or 13 data sufficiency questions were there. For example, this 13th question onwards, all these are data sufficiency problem. Try the 14th question, the odd number, even number idea we discussed. That idea is also needed, and the factor idea is also needed. Can you do 14th question? Those of you fear math, I want to tell you some general things. If you fear math, just think that math is a life skill you are learning. Just like cycling or swimming. The first day of swimming or first day of cycling, you have thought for sure that you will never learn this, no? Because it was like impossible. You will feel like this is something that how others are doing. Like I can never do it, right? But still you have, I don't know, some of you may say, I don't know both of the skills. Think about any skill you learned. You learned by taking an effort. So all those skills took some time, na? For that time, you were patient enough. And for example, in the case of cycling, first you have put 2 extra wheels for the cycle, right? With that you learn. After that, you remove the wheels. Same thing. Here, I will also give you some help in the beginning. Later, you can do it yourself. So that patience should be there. That is what I'm trying to say. In the first question, second question, you may not understand the question also. That is totally fine. But don't stop trying. If it is something that is difficult to learn, you have to invest some more time or some more patient effort is needed. So that is my general advice about learning maths. So please try 14th question. If you are not understanding the question also, read it 2-3 times. I'm starting from the difficult or most difficult topic itself. Number system is the most difficult topic compared to any other chapters. Why? Because without learning number system, you cannot learn other chapters. For example, percentage fraction, you will need the ideas you are learning in this chapter. So that is why even if you feel little difficult in the beginning, you will get adapted to it. So don't worry. So try this question. This was the 2024 PYQ. After this question, we'll take a break. Yes, C. All of you tried? How many of you got C option? I'll wait for one more minute. If 14 is done, you can try 13th question also. I'll explain the meaning of the question. What is a data sufficiency question in general? I will explain. So in data sufficiency question, always there will be a question. You don't have to answer this question. Question is only asking, for answering this question, which of these statements are needed? Is this statement alone is enough? That means if you have this as the clue, is that only enough to finish this question without using this? That is the meaning of question can be answered by using one of the statements alone. Which is that one statement is not mentioned. In some question that will be mentioned. Statement 1 alone is enough. Statement 2 alone is enough. Here that is not the way the options are structured. Here the question is saying question can be answered using one of the statement alone. Maybe statement 1 alone, maybe statement 2 alone. Another option is saying question can be answered using either statement alone. That means with statement 1 also you can solve it completely without the help of statement 2. With statement 2 alone also you can answer it without the help of statement 1. That is the meaning of second option. Third option, question can be answered using the statements together but cannot be using either statements alone. If you use both the clues, you can solve it, but with one clue only you cannot solve it. That is the third option. And fourth option is question can be answered cannot be answered even by using both clues. With these two clues, if you use also, still you cannot answer it. So meaning of the question is clear now. Now what we need to answer, what are the unique values of x and y, where x and y are distinct natural numbers. 1, 2, 3 up to infinity only you need to consider. There should be different numbers also. First of all, without statement 1 and 2, you cannot do anything now, because we only know x and y are distinct natural number. There are infinite many distinct natural number now. 1 and 2, 1 and 3, 1 and 4, 1 and 5. Which are the, so the question paper setter is asking, what are the two numbers that is there in the mind of the question paper setter? Without any clues, you cannot answer it for sure. So let us use the first clue. X by y is odd. So if the first clue only is enough, what does that mean? There is only one case in the all number system that one number by another number is odd number. That is wrong. Na? 3 by 1 is odd. 7 by 1 is odd. Odd number by odd number is always odd number. Na? If it is divisible. And if 1 is taken as the denominator, that itself gives you infinite cases. Na? 3 by 1, 5 by 1, 7 by 1, 9 by 1, 11 by 1. So this statement alone is not enough for sure. Because no other clues we have about x and y. X and y can be any natural numbers, any distinct natural number. So statement 1 alone is not enough. Let us take statement 2 alone. Forget about statement 1 now. Think about statement 2. X into y is 12. If x into y is 12, what are called x and y? What is the name of x and y? Factors. So question is asking, if 12 was a prime number, x and y will be unique. Na? If it is say 11 into 1. But still 11 into 1, 1 into 11, both are possible. But 12 is not a prime number. So definitely there are many factors. So you have to list out the factors. This is how the factor idea will help you. And please write factors as pairs only. Otherwise, you will be confused actually if you try to list factors without pairs. So start from the smallest natural number, 1. 1 into what is 12? 1 into 12 is 12. So 1 and 12 is a possibility. If you start with 2, 2 into 6 is 12. If you start with 3, 3 into 4 is 12. If you start with 4, 4 into 3 is 12. 3 into 4, 4 into 3 are different. X and Y are different numbers. No? So 4 into 3 means 6 into 2 is also there. 12 into 1 is also there. These are the pairs. Yeah, when you say X and Y, 2 numbers only, these 3 pairs only are enough. But X, Y, Y, X both are different. That is why 6 pairs are possible. Are you getting? That means statement 2 alone is enough or not? No. You should get a unique answer. To answer a question, for example, if I ask you what is your name, if first you say Rahul, then you say Raj, that is not correct. Na? I should get a single name, then only I get the answer for it. Na? Same way, I need a single set of value for X and Y. Then only we can say I have answered the question. Here, X and Y can be 1, 12, 2, 6, 3, 4, 4, 3, 6, 2, 12, 1. That means statement 2 alone is not enough. So which option is eliminated? Tell me. Let me see whether you understood the meaning of data sufficiency questions. For the first question only, I will do this. That's why. Which option is eliminated? From whatever I have discussed till now, which option is eliminated? Or which all options are eliminated? Question can be answered by using one statement alone, but cannot be answered using other statement alone. I told you now already, statement 1 alone, you cannot answer it. Statement 2 alone, you cannot answer it. So the first part itself is wrong. Can be answered is wrong. So this option is eliminated. Now, question can be answered by using either statement alone. That is also not possible. So first statement alone is not enough. Second statement alone is not enough. Question can be answered by using statements together. That we haven't checked. Together we haven't checked. But cannot be answered using either statement alone. Second part is correct, but first part is correct or not, we don't know. So keep it hold. Fourth option, question cannot be answered by using. That also we don't know now. First we have to check together what will happen. Okay, so now these two options eliminated, all of you are clear, na? A and B option, why it is eliminated. Now C and D option, for that you have to use both the statements. Statement 2 says this much values of X and Y are there. Statement 1 says infinitely many values of X and Y. If you combine these two, statement 2 restricts the values to these 6 possibilities. That means if you apply to statement 1, X by Y means 1 by 12, 2 by 6, 3 by 4, 4 by 3, 6 by 2, 12 by 1. That are the 6 cases. Question says that should be odd, na? For it to be odd, first of all, it should be divisible. 1 by 12 is not divisible. So this case is eliminated by the first statement, because when you divide it, you are not getting odd number. You are getting a fraction. Fraction is not odd number. Odd number should be integers only. 2 by 6, is it possible? No. That is all improper fraction. Sorry, proper fractions. Na? Numerator less than denominator. Numerator less than denominator means it cannot be divisible at all. So this is not possible. 3 by 4 also numerator less than denominator. So that is not possible. Here onwards, it is numerator more than denominator. But still, you have to check whether it is divisible. 4 by 3. 4 mango divided among 3 people. Definitely there is a fraction. First, you can divide each of them 1 mango. Remaining 1 mango among 3. So 1 by 3. So that is not divisible. If not divisible, you cannot get odd number. So this also you should not consider. 6 by 2, divisible, na? 12 by 1, divisible, na? Divisible means check whether you are getting odd or not. If it is 6 by 2, 3, odd number. 12 by 1, 12, even. That means this case we don't want. Why? Because X by Y is not odd, it is even. That means only one case remains. 6, 2. That means X value should be 6, Y value should be 2. There is no other way. All of you are clear? No other way means by using statement 1 and 2, you are getting a unique set of value for X and Y. There is no 2 set of value or 2 or more set. That is why the answer is question can be answered using statements together, but cannot be answered using either statement alone. Option C. Is it clear, all of you? This is how to analyze a data sufficiency problem. Any chapter questions can be asked in this format. This chapter itself, 4 questions were asked from data sufficiency model itself. 13, 14, 15, and 16. All these 4 questions from this chapter alone asked in 2024. So shall we take the break? How much time is the break normally? 10 minutes, okay. So try the remaining questions if you are coming back fast. Try the remaining questions. We have to complete one more topic today if possible. Otherwise, we will start that topic and remaining will continue tomorrow. And if there is any doubt, you can bring the doubt. I will be there in the office or outside. Online batch, is it all clear what we discussed till now? Please use the chat box to post your concerns. So shall we start? So this question, did you try question 13? Any answers? 2024 PYQ. Option D. B. How many of you got B? D option, how many of you? Any other answers? Still trying? C. Let's see. I'll give you 30 seconds more. Make sure you have completed trying that question. It is somewhat similar to that 14th question. Now, here also the factor idea is needed. Options are similar to the 14th question itself. The meaning of the options I'm not repeating. All of you are clear now. Statement both are needed or one is needed or both are not enough. That is what the structure of the question is. Okay, let's start. Statement 1 says m plus, okay, first thing, question is what are the values of m and n where m and n are natural numbers? Just like previous question, only thing told is m and n are natural numbers. There are infinitely many natural numbers. So without statement 1 and 2, you cannot solve it for sure. What is statement 1? M plus n greater than m into n. That means sum of two numbers is greater than the product of two numbers. That is how you have to understand it. Don't just mathematically only think it. In real life, if you think two numbers sum is greater than the product of it. Take money in, for example, if you have 10 rupee and 2 rupee. 10 plus 2 rupees, 12 rupees. Na? But 10 into 2 rupees, what? 20 rupees. So which is bigger? 10 into 2. Na? But here the question says, sum should be greater than the product. Sum should be greater than the product means, normally, I'll tell you the general property. When product normally is bigger than sum most of the cases, but we need the other way around. That means we need the product to be small. For the product to be small, one number should be 1. That is one easy way to say. Because if you multiply by 1, you are not increasing the number. Getting the point? But when you are adding by 1, you are increasing the number by 1. Are you getting? So, for example, 20 into 1 is 20 itself. The number 20 I am fixing. If you are multiplying it by 1, you are not increasing the value of 20. But if you are adding by 1, you are making it 21, bigger than 20. Na? That means what we understood is, for the sum to be greater than the product, one of the number should be 1. Clear? The other number can be anything. How many possibilities are there for that? Infinitely many. Na? 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1. So m and n, there are infinitely many possibilities. N should be 1 because one more condition is there, m greater than n. That means n should be 1. This is how to process it. When you see a question, this is how to process it. Take few examples and make a generalization. So we generalize that n should be 1 by this. M can be anything according to first statement alone. That means first statement alone is not enough to answer the question. What is our requirement? To find unique value for M and N. One single set of value for M and N. That is when we say we solved it. As I told, when I'm asking you what is your name, I need a unique answer. I don't want 10 names of you. I want only single name of you, right? Same thing, I want only single set of values for M and N. That is when I say I solved M and N. Getting the point? So statement 1 alone is not enough. We understood it. Now statement 2 alone. M into N is 24. That is what is written. That we already discussed in the last question. Na? Product is 24. If 24 was prime number, M and N, still M and N, N and M, both are possible. But here it is not prime, so many possibilities are there. What are the possibilities? 1 into 24. I'm not writing it down. It is just same as previous question. Na? 1 into 12, 2 into 6, we wrote. Na? Same way, 1 into 24. Think about 2. 2 into 12. Think about 3. 3 into 8. Think about 4. 4 into 6. And the reverse of all these 4. Reverse means 4 into 6 means 6 into 4 is possible. 3 into 8 means 8 into 3 is possible. You note down the 8 numbers. 2024 questions, I haven't typed the solution of all of it. But all the previous questions, I have typed the solution. So 2024 question, you can note down the solution if you want. So 8 numbers, did you understand? 8 pairs are there. So second statement alone is not enough. Why? Because 8 answers I get. I want single answer. Nah. Single answer I'm not getting from statement 2 alone. Now the only option is combining both the statements. From the first statement, what we understood, N should be 1. M can be anything. N should be 1. For N to be 1, the only possibility for M is 24. Na? If you use the second statement, 24 and 1. All of you are getting the point? So if you combine both the statement, we understand that M should be 24, N should be 1. We got the point N is 1 from the first statement. Because if N is 1 only, the sum will be more than the product. From the second statement, what we understood, sum being more than the product, that is 1 should be N. 1 being N, there is only one product, where N is 1. 24 into 1. That means combining both, we solve the value for M and N, 24 and 1. Unique value. Na? There is no other possibility for N to be 1 and M to be different. M can only be 24. Factor idea we used. So what's the answer? So question can be answered by using both statements together, but cannot be answered using either statement alone. C option is the correct answer. Clear? So that is how data sufficiency problems should be done. Compared to other question here, solving the value is not relevant at all. For solving, what is needed only is relevant. So 15th question, check it. 13 and 14 question was connected to factors mainly. 15th question is connected to your understanding about prime number. I told you, first few prime numbers you need. I am analyzing UPSC question papers of the last 12 years rigorously. From that, I am telling you what all are more important for you to learn. So when I am saying prime numbers below 50 are needed, I am telling it by checking all the PYQs. So only bare minimum things I am telling you to by heart. So those things please by heart, because I am totally against by hearting things. So when I am saying something to by heart means that was repeatedly asked in exams. There are chances for it to be repeated also. So strictly according to PYQs, I'm telling that, right? So prime numbers, when I'm saying by hearting,
sir, excuse me, sir.
Prime numbers, you will.
Sir, one doubt here. In this question, they are asking what are the values of M and N. They have not asked unique values of M and N. So there can be any number of values for N, any number of values for N.
That is a good doubt. But question is asking, what are the values of M and N means? Here again, if it was a linear equation, you can say there can be multiple solutions. That is called inconsistent solution. But please understand, in these kinds of questions, we don't want inconsistent solution. We want consistent solution. Consistent solution means unique set of values. As I told, again, I'll tell you, if it is unique, if it is not unique, for every question, the answer will be, you can solve it without using any statements. Na? Because if you extend your doubt, then the values can be infinitely many also. Na? So none of the question
Yeah,
need
then
any of the
that should be the answer, right?
Yeah, that is what
It
I'm
can
saying.
be answered without using any of the statements. That should be the answer then.
No, that is not the answer, because I'm saying then infinity is the number of solutions. Na? If there is
Yes.
more than one solution itself, that is not a solution at all. For example, again, in linear equation also, as I told, that is called inconsistent solution. Means inconsistent solution means we are not getting a set of solution that we need. We are getting more than one set of solution. That is not a solution at all. Again, answer me then. If you think that two solution is possible, why can't it be infinitely many solutions? If you don't use, that means for any question, no statement is needed to solve. Na? Because by default, this statement is itself is enough to say at least one value for m and n. What are the values of m and n? Where m and n are natural number. So I can take 1 and 2. 1 and 2 are natural number, solution. 1 and 3, solution. 1 and 4, solution. So for every question, you can answer it without the help of statement 1 and 2.
But if in the question, if they ask unique values, then there can be only one.
No,
But in this
that is
case,
not the unique values. When I'm saying unique value, I'm saying unique solution. Solution should be unique. Solution should be unique means, if I'm saying what is a requirement for us, we want the value of m and n. We want the value of m and n. So what is the base of algebra? When I'm saying x plus 5 is equal to 3, the only possibility for x is minus 5. Sorry, x plus 5 is 0. Minus 5 is the only possibility for x. If I am saying that x can be infinitely many values, that is not a solution for x at all. Same way, if I am getting more than one solution, that is not a solution at all. Again, I think the doubt is from your linear equation itself. The idea of inconsistency is there. But in these kinds of questions, inconsistency have no role at all. We want consistent solution. That means unique solution. With the further question, I will give you why it is so. You will get more idea. This question, I understand that idea, that doubt can be there. Why can't it be more than one value is also possible? But that is not the meaning of the question. That you will get more realization in the upcoming questions. So try the next questions. The question. Any answers? C. So now you have cracked the code or cracked the pattern. These kinds of questions all are C option. Let's see whether it is C option. What is C option? Cannot be answered. C is wrong. C is wrong. I'll tell you why. So listen very carefully. B. Okay. A. D is remaining. Anyone? Okay. There are three distinct prime numbers whose sum is a prime number. So this is a premise of the question. This is not statement. This is a premise. So one extra premise is there. Three distinct prime numbers whose sum is prime number. For example, if you take 2, if you take 2, 3, 5, is it a prime? We have to trial and error first to get an idea what the question is saying. 2 plus 3 plus 5 is not a prime number. So 2 being there is a problem, na? Because 2 is an even number. This odd plus odd is odd. Sorry, odd plus odd is even. That even plus even will always be even. So if you include 2, that will not work for sure, because you are going to get even number. Except 2, all other even numbers are non-prime, na, composite. Na. That is why 2 should not be taken. We understood it. 3 plus 5 plus 7. I am starting from the smallest prime number set. 3 plus 5 plus 7 is what? 8 plus 7, 15. Not a prime. 3 plus 5, instead of 7, next prime is what? 11. 3 plus 5 plus 7 is what? 11 is what? 19. That is a prime. So this is satisfying. Na? This is one possibility. 3 plus 5 plus 13, 21. Not a prime. This should be a prime. That is what the question says. Three distinct prime numbers whose sum is a prime. We need to find the three numbers. So 3, 5, 11 is a possibility. If that is the only possibility, that means we answered it without the help of statement 1 and 2 also. There is no such option says it can be answered without statement 1 and 2, because that won't be there. At least one of it or none of it. That is the idea. So 3, 5, 13, 21. 3, 5 after 13, what is the next? 17. So 21 plus 4, 25. Not a prime. 3, 5, 19. Yeah, I haven't used statement 1 and 2 yet. I'm just showing you there is at least 2 solutions for this. I haven't started using statement 1 and 2. I just want to see whether there is more than one solution for this because if it is more than one solution, if there is only one solution, that means we can say we can answer it even without the help of these two. Na? That is what I'm trying for. So 3 plus 5, 8, 8 plus 17, 3 plus 5 plus 19, 27, not a prime. So 3 plus 5 itself is not working, we are getting. Yeah, so we can try with 5. 5 plus 7, we avoided 3. The next smallest case is 5. Na? 5 plus 7, 12. 12 plus what? It should be distinct also mentioned. Na? Distinct. So 9 is not possible. 11. 5 plus 7, 12 plus 11, 23. So this is at least second solution. Na? I just wanted a second solution. That is why I tried all this. This is not necessary. I'm just giving you what is the meaning of the question. So at least 2 solutions are there. So definitely at least one of these statements are needed. So that is now what we are searching for. Statement 1 alone is enough to find the 3 numbers or not. Finding the 3 numbers, their sum is less than 23. That means less than 23, how many possibilities are there? If there is only one possibility less than 23, that means this statement alone is enough. Na? So you have to list it out. As I told, you should have good understanding about what all are the primes. So 2, I told you 2. If you involve 2, you can never get the sum as prime. It will be composite for sure. So 3, 5, 7 combination we will write. 3, 5, 7. We already discussed this. 3, 5, 7 is what? 15, not a prime. 3, 5, 11, 19 prime. So this is one valid possibility. Now, let's see whether you can make it less than 23 or not. 3, 5, 13, 21 not possible. So now if you take whatever value here, that will be above 23. No? Are you understanding the point? This is how to systematically find it. For giving you the solution, I can just say that this is the only possibility. But in exam hall, how you should list it out, that is what I'm trying to say. 3 plus 5, 8. 8 plus 17. 8 plus 17 is what? 25. That is above 23. Na? That means the only possibility below 23 is 19. Okay, we have to try one more thing. Whether 5 and 7, whether you get anything below 23. 5 and 7, if you're taking 5 plus 7 is already 12. So to reach 23, what is needed? 12 plus 11 is 23. So 5 plus 7 plus 11 is also 23. But 23 is not less than 23. Question clearly says it should be less than 23. So below 23, you cannot make any other possibility other than 3, 5, 11. That means when this extra information that their sum is less than 23, we understood that only possible value for x, y, z is, the 3 prime numbers x, y, z is 3, 5, no, 11 is 23, na? What is the value?
No, 11.
Yeah, 3, 5, 11, sorry. 3, 5, 11, that is 19 will be the sum. 19 is the only sum below 23 you can obtain. That means statement 1 alone is enough to finish the question. We haven't used statement 2 yet, na? But there is a possibility that statement 2 alone is also enough. That we have to check, na? Statement 2 alone is enough or not. One of the numbers is 5. That means that is a help we are getting. One of the numbers is 5. Already question is saying. From our previous understanding, we understood that if one of the number is 5, 3, 5, 11 is possible, na? 3, 5, 11 is a possible value. What other values are possible? Avoid 3. Avoiding 3 is the next possibility, na? Avoiding 3 means the minimum possibility is 7. 5 and 7. 5 and 7 is 12. 12 plus 11 is 23. Na? 12 plus 11 is 23. That means already 2 set of values I got with 5 alone. Whether there is a third set, that is not my concern. Because statement 2 alone is not enough to finish the question. Why? Because if you use statement 2 alone, There is no unique solution. There is two solutions because 3, 5, 11 also is 23. When you are using statement 2 alone, statement 1 is not existing at all. Statement 2 alone means 5 including triplets, how many are possible? Minimum 2, na? Because there is no limit of the sum. What should be the sum? It can be any big sum. So it can be above 23 or equal to 23 also. Here it is equal to 23. The sum less than 23 part is not coming when you are considering second statement alone. That means what we concluded, statement 1 alone is enough to finish the question. Statement 2 alone is not enough to finish the question. Which option is saying so? Let us check each option. Question can be answered using one of the statement alone, but cannot be answered using the other statement alone. To be more precise, question can be answered using statement 1 alone, but not with statement 2 alone. So option A is the answer. Is it clear? First, you should understand data sufficiency problem. What is the meaning of each option? Yes. Which thing? Yeah. Here the word distinct is given. That is why we are not repeating. All of you clear? Again, I don't want this course to be just like a namesake course. I want everyone to get concept clarity. So please feel free to ask your doubts. If you want me to repeat, I will repeat. Should I repeat? Okay, I'll just summarize once more. Because if you understood, you can try the remaining questions. So here the answer is option A because statement 1 alone is enough to finish the question. Because statement 1 says sum is less than 23. When you trial and error, how to systematically trial and error, I told you, avoid 2 because with the properties of prime number, sorry, odd number, even number, we understood that. If you include 2, you will get the sum as composite number. Composite number is not composite number, sorry, you will get the sum as even number. Even numbers are generally composite. Na? We need prime sum. That is why 2 should be avoided. So you have to start with 3. So you are trial and erroring. How many sums less than 23 you are getting? Only one sum less than 23. 3 plus 5 plus 11. 3 plus 5 plus 11 is 8 plus 11, 19. 19 is the only possible sum less than 23. If you trial and error, you are getting. Next possibility is 23 sum, but less than 23 means 23 cannot be included. The only possibility for the sum to be less than 23 is taking the numbers as 3, 5 and 11. That means we are getting unique solution for the 3 numbers. 3, 5 and 11 are the solution. So statement 1 alone is enough to finish the question. Why statement 2 alone is not enough? Because if one of the numbers is 5, 3, 5, 11 sum is also prime number. 3 plus 5 plus 11, we already discussed 19. Na? 5, 7, 11 is also 12 plus 11, 23. This is also prime number. Na? That means with 5, at least 2 values are there. Maybe more than 2 also. But when you are getting more than one solution itself, we understood that that is not a solution. Are you getting? When I ask you in the last class test, how many marks you got? I should get a unique value from you. You cannot say I got 22 marks and also I got 32 marks. No. Same way, I need only one solution for this. But I am getting multiple solutions if I use second statement only. So second statement alone is not enough to finish the question. But first statement alone is enough to finish. Clear? Yes. I know this is exhausting. After a point of time, we will feel like I should stop doing these kinds of questions. But there is no option. Last few years, they are constantly asking these kinds of questions. Yes. Yeah. Yeah. For this question, this one, na? Actually, because this condition is saying less than 23, na? Less than 23 numbers are all two-digit numbers or one-digit number, na? That is fine. Yeah. Yeah, but the problem is, if we take that, how many numbers we will take? We'll take infinitely many numbers are possible. Na? That is why we are using statement 1. Statement 1 restricts our condition that we need only sum less than 23. That will help us to solve faster. That is why we are starting with this condition. In this condition, can you take any 3-digit number? No, right? That is why this condition, question is asking statement 1, if you take it as a clue, can you solve the question? So we took statement 1 as the clue. The clue is sum should be less than 23. Sum less than 23, we cannot start with 3-digit number because sum itself is 2-digit number. So the numbers cannot be 3-digit. Yeah. No. The requirement is to get the solution. Requirement is not to not get the solution. Na? We need at least one solution. For that, our range should be below 23 only. Because we are trying to say, yeah, I understood what you mentioned. What you mentioned is XYZ can be anything. I totally agree. But we understood that statement 1 says that, for example, I told you an example that how much marks you got when I'm asking you. If you tell me that you are not telling me clearly the answer, but you are saying that out of 200, I got less than 100. So I will not search for more than 100. Na? So I will now ask, how much less than 100? Because I know that the clue you have given us, the mark I got is below 100. So I don't have to search above 100 now because I got a clue already. The clue is already given that the value is below 100. So I will ask, is it between 90 to 100? I will not ask, is it now above 100? Na? Because you already gave me the clue that the answer is below 100. Yeah, these, there is a game show also, na? Where like a set of 7 yes or no questions will be asked and we will be able to guess the person in the mind. So in that game show, if a person is asking, is the person male? If the answer is no, we will not ask, is the person female? Na? Because we know the implication. If the person is not male, what he implies is the person is female. Same way, we know that the sum is less than 23. Sum is less than 23 means sum above 23. We don't want that at all. X and Y and Z can be above 23 also, but that will not satisfy this clue. This clue is existing. Then what is the solution? That is what we are searching for. Getting? So this one, 16th question. Once again, I'm telling, please bear with me to complete this number system unit. After that, you can choose which all questions you can do, which all questions you cannot do. Because after completing number system only, we can go to the simpler topics. This base is needed for that. Even if you are not able to find all solution, that is totally fine. But what you gain from this chapter will help you for other chapters also. This is the toughest chapter. The next is 5 topics. 6 topics totally. 1 topic we have completed today. The remaining topics also. Today I'm going a little slower. So the second topic most probably today I will not be able to start. We'll complete this first topic and then tomorrow onwards we'll go a little faster. The worksheet of tomorrow, try it and come so that we can finish those questions faster. Anyone tried this? B. B for bad, na? Okay. Question can be answered using statement. Okay. So the question is x plus y is an integer. First of all, x plus y being integer, there are infinitely many possibilities. Na? An integer plus integer is always integer. Na? Integer plus integer is always integer. But is it the only possibility? Integer plus integer can only be integer, or rational plus rational also can be integer. What do you think? If I have 1/3 of pizza and 2/3 of pizza, I will make a whole pizza. Na? Whole pizza means integer. Getting the point? I first took, like, I have a pizza in front of it, in front of me. I'm cutting it into 3 parts. First, I thought like I will diet and I will take only 1 out of 3 pieces. So I had 1 piece. After that, I felt it is very good pizza. So I will have the remaining 2 out of 3 parts also. So mathematically speaking, what I did there is 1/3 plus 2/3. Na? That means I got the whole pizza. I ate the whole pizza. That means a fraction plus fraction can be non-fraction. Are you getting the point? Or rational plus rational can be integer. Integer is rational. That is another thing. But that is integer, na? 1 by 3 plus 2 by 3 is integer. 5 by 6 plus 1 by 6 is integer. Even if 5 by 6 and 1 by 6 are not integers. Getting the point? So x plus y being integer does not mean x and y are integer. That is the first thing you should understand. Now, we need unique values for x and y. Na? We need unique values for x and y. We don't want to say 1 plus 2 is integer, 2 plus 3 is integer. No, I want x1 value, y1 value, no other values I want. A single set of values. That is when we say we solve the solution. As I told in the case of example, like how much mark you got. You told me more than 100. Then it can be 101, it can be 102, it can be 103. If it is out of 200, there are already 100 possibility. Fractions are also there. There are more possibility. So that is not a solution. I didn't get how much mark you got. I got only a range that you got between this to this. But what I wanted is a unique solution. Na? Same way I want a unique solution for x plus y. Sorry, x and y. So statement 1 alone is enough or not? Let us check. 2x plus y is an integer. It is saying that 2 times a number plus another number is integer. Does that guarantee x plus y is integer? That means if 2 times x plus y, if it is integer, can you say x plus y is integer always? Let us trial and error. First, we will take the simplest example, x be1, y be2, both being integer. 2 into 1 plus 2. 2 plus 2, 4, integer. Na? If x and y are integer, this will definitely be integer. X plus y is also an integer. So the answer to that question is yes. So here the question is x plus y value. Is it always integer? So the possible answers are yes or no. So if you are saying yes, it should only be yes. It cannot be no for another example. That is a uniqueness here. In previous question, uniqueness was how many set of value? Is it one set only? Here the uniqueness is this question, the answer should be always yes only or always no only. So when I am taking x is 1 and y is 2, the answer for this question is yes. Na? Are you all agreeing that? But what if I am taking another example where x is half, 2 into half. Pizza's double, half of a pizza double is a full pizza. Na? So that is an integer. Are you getting? 2 into half is an integer. So if I take another integer for y, integer plus integer will be integer. Are you getting? So this condition is satisfied for the example. If I am taking x is half and y can be anything. Y is 3. What is the value for this? 2 into half, 1 plus 3, 4. Na? So this is satisfied. Substitute that here. The x I have taken as half, y I have taken as 3. Half plus 3. 3 mark plus half mark is how much mark? 3.5 mark. This is a mixed fraction. Integer is not a mixed fraction. It should be always a proper fraction. So, or improper fraction. But 3.5 means it is 7 by 2. It is not an integer. Na? Are you getting the point? So now the answer we have changed to no. When you took x is equal to 1, y is equal to 2, the answer was yes. Now the answer is no. Is it unique? No. That means I didn't get unique solution with statement 1 alone. If I use statement 1 alone, I will not get unique solution. Sometimes I'm saying yes, sometimes I'm saying no. That is not solution. Na? Did you pass the exam? You said yes. After some time, no, I haven't passed the exam. No, that is not a solution. I want a definite answer. Whether you passed or not, that is not my concern. I want the answer for it. Are you getting the point? Maybe, maybe not. That is also not an answer. After checking your result, I'm asking, did you pass the exam or not? So either the answer should be yes only or the answer should be no only. Otherwise, that is not an answer. Same way, for this question, either the answer should be always yes or the answer can be always no also, but it should be consistent. Here the consistency is yes or no. In previous questions, the consistency was one set value or two set value or more than one set value. If it is one set value, that is correct. Here also one set value, either yes only or no only. But I'm not getting one set value. I'm getting two set values. No? Are you understanding? So statement 1 alone is not enough. Do the same analysis for statement 2, please. Statement 2. Statement 2 is identical to statement 1. Na? Just x and y are interchanged. Like x plus 2y, I can write it as 2y plus x. 2y plus x and 2x plus y is same. Na? That means statement 2 alone is not enough. Same example itself. Instead of x1 and y2, y1 and x2. Similarly, y half and x something else, some integer. First case, I will get the answer yes. Second case, the answer no. So that means statement 2 alone is also not enough. Now what is our next thing? Is both together is enough or not? Both together, be very careful here. The example that you should be taking should satisfy both. Satisfy both means the x and y I am taking should make 2x plus y integer also, x plus 2y integer also. So you should be careful. For example, if I am taking half here, 2 into half, 1. That means that half itself only I can take here also. So when you are taking y now, you should be careful there. Half into some, half plus something should be integer. Half plus something should be integer means I can take 1 by 4. 2 into 1 by 4, what it is? 2 into 1 by 4, quarter plus quarter. Quarter of a pizza plus quarter of a pizza is half pizza. Na? So half plus half is 1. Na? Are you getting? So that is okay. What about this? No, here it will not satisfy. So taking half itself was a mistake. Taking half is not enough. Let us take some other example. Let us take 3 by 4. One second.
Sir, can you add those two things?
Sorry?
Can you add that 2x plus y and x plus 2y? Because you'll get 3x plus 3y. Considering both of them as integer, you'll get 3 into x plus y. If you want, 3 is always an integer, and x plus y can be 1 by 3 and other integers also. So x plus y is not always an integer.
Okay, good point. I'll come to that. What he told, I'll explain it. But with what he told, I will take a number satisfying that. Say maybe 1 by 3 will work. 2 times 1 by 3, 2 by 3 plus 1 by 3. Here both are fractions. Na? Both are fractions. 2 times 1 by 3 plus 1 by 3. And here it is 1 by 3 plus 2 times 1 by 3. What will happen? 2 times 1 by 3 plus 1 by 3. That is 2 by 3 plus 1 by 3. 2/3 of a pizza plus 1/3 of the pizza will make a whole pizza. 1/3 of a pizza plus 2 by 3. 2/3 of a pizza. 2/3 means out of 3, 2 parts you are taking. 1/3 means out of 3, remaining 1 part I am taking. So that means I took the whole pizza. Na? So that means in both cases it is integers. Na? But still x plus y, is it an integer? 1 by 3 plus 1 by 3. 2 by 3. That is not an integer. Na? So here I am not getting an integer, but I can make it integer also. How? Take natural numbers. Take natural numbers here. I will write it down. If x is 1 by 3, y is 1 by 3, x plus y, not an integer, not integer. X is 1 by 3, y is 1 by 3 satisfies both the two statements, because 2 times 1 by 3 plus 1 by 3 is integer. 1 by 3 plus 2 times 1 by 3 is also integer. So this case, not an integer is the answer we are getting. But what if x is 1, y is 1? Or x is 1, y is 2? Then x plus y will be 1 plus 1, 2, integer. Na? That means answer can be still yes and no simultaneously. That is not a unique solution. Okay, how are you feeling? I don't know. But this is how the question comes. To be frank, in exam hall, you will be totally confused when you see this question. This set of example, before exam hall, if you are not practicing, this is not easy for the first time when you are seeing this. For the first time, this is a question that should be skipped. But if you have seen these kinds of questions before exam hall, these examples will come into your mind. Yeah, when I'm saying now, I am saying easily, I can take an example like this because I have seen this question outside exam hall. Inside exam hall, I will also be confused which example to take. Maybe one case I will get, second case I won't get. By that, I conclude that it is not an integer always, or I will take always integer. So this question is really confusing. If you are seeing it for the first time, better to skip it. Always remember, you have choice to answer. It is not like 80 questions. You cannot do 80 questions. The time is not enough. 80 questions, 120 minutes means 1.5 minutes only. To read this kind of a question itself needs 1 minute to understand it. Na? The length of the question itself says so. So first, please keep in mind, every question understanding, every question solving, that is not the objective. Maybe in GS1, that may be the objective because we don't know how much is the cutoff. The competition is increasing every year and the cutoff can go any higher. But in CSAT, please keep the strategy. What I'm saying is don't get demotivated when you see 2-3 questions like this. All questions are not like this. All chapters are not like this. But without this chapter, we cannot start any other chapter. That is the only reason I'm frightening all of you with these questions. Because without this chapter, there is many gaps that will be there in other chapters. Then I have to start from the beginning again. So now the difficult chapters itself we will start. But are you getting the solution? What I'm trying to explain. This solution, whether you get in exam hall, that's a different thing. But this is what UPSC expects from you when you see this kind of a question. Clear? This question's little more simpler version is question number in 2023 it was asked. 22, I guess. Question 22. Question 22 itself. That's a simpler version of this question. Instead of 2 integers, 1 integer. But the idea is similar. Can you try question 22? Last three years or so, that is when these kinds of questions are more coming actually. Earlier number system questions were much lesser. From 2022 onwards, they have increased it. Yeah, to be frank, that is when students started attending coaching also. Otherwise, before that, it was an exam or a section that you can even clear if you just practice few PYQs. But now the problem is the toughness, especially these kinds of chapters, if you are not clear, you have to invest some time on this by the proper methods. So that is what I am guiding you. Try more and more questions with these methods. Try to complete all the questions in the worksheet. Minimum that much you try. And now after that, if you want more question, I will provide it. Or there will be regular test and all here. Na? So that itself will boost your confidence. Here the options are little more smaller. It is specifying which statement alone is enough. That is little more easier actually. In the previous question, they didn't specify statement 1 alone or statement 2 alone. That we have to decide. But here, options 1 says statement 1 alone is enough. Option 2 says statement 2 alone is enough. That is little more easy to eliminate actually. And little more faster, you can read the options also because of the length of the statements. Yes. Decimal numbers are fractions or they are rationals. Option A. Okay. Any other answers? C. Again, when you are feeling these kinds of questions are very difficult, try to relate it with practical examples. I told you, na, I asked you a question. What is the marks you scored? So the clue you are giving me is above 100 is the mark you scored. That means, is it enough to answer the question? Because above 100 means 101 is a possible value. 102 is a possible value. 103 is a possible value. So first clue is not enough. So I'm asking you one more clue. So you gave me below 110 is my mark. Is it enough to solve? Because above 100, below 110 together also, I restricted the range, but still the answer can be any value between 100 to 110. Na? The same thing is asked in the question also. First clue enough or not to get the unique set of solution. When I am asking you what is the mark you scored, what is my objective? I want to exactly know what is the mark you scored. Na? I don't want a range of marks. I want an exact answer. Same way here, I want the exact answer. The question is X an integer? That means X should not be a fraction. X should be an integer only. Fraction means fraction without denominator as 1. Fraction with denominator as 1 means that is an integer itself. So what's the answer? Option A, how many of you? Option B? Option C? Option D? Others? Tried? Meaning of the question, did you understand? So is X an integer? Integers, there are infinitely many. So you need at least one clue. Na? Without that, X an integer means X can be any number. 1, 2, 3, 4, 5, 6 up to infinity. -1, -2, -3 up to infinity. Anything can be possible. So the first clue is X by 3 is not an integer. X by 3 is not an integer. Let us take example. 3 by 3 is an integer. It's an integer. So that clue is not, I mean, that example is not enough. So that means I should take a numerator which is not a multiple of 3. That is what we understood now to satisfy clue 1. Related to the example, how much mark you scored? When you told above 100, I restricted my understanding. Above 100 means it cannot be 99. Same way, X by 3 not an integer means X should not be a multiple of 3. Because multiple of 3 means 3 and 3 will cancel. Na? So non-multiple of 3, say 5 by 3. X can be 5. X can be 7. X can be 8. X can be any number other than multiples of 3. Na? So statement 1 alone is not enough. So option A is eliminated anyway. Because X by 3 not an integer means X can be 7 also, X can be 11 also. Any non-multiple of 3 is okay. Non-multiple of 3, infinitely many are there. Na? All of you understood this. Why option A is eliminated? Clear or not? Yes. Now option B alone we will check. 3 times a number is an integer. 3 times a number is an integer. Does that means number is integer? Very good. 1 by 3 is not an integer. But 1 by 3 and 3 will cancel na, to make it an integer. That means if X is 1 by 3, 3X is an integer and X is an integer. Sorry. Yeah, I'll take it. If X is 1 by 3, 3 into 1 by 3 is an integer. 3 into 1 by 3 is an integer, but still X is not an integer. So what is the conclusion? The question is not asking whether X is an integer at all. That is not our question. That is a question in the question. But our question is, will you get a unique answer for it? Here the answer is no. Now the question is, can you make it yes? Can you make it yes by taking another example? Yes, definitely. 3 into 1 now. 3 into 1 is 3. Here 1 is integer. That means in this case, in the example, X is 1, 3X is an integer is satisfied. So X is an integer. Yes is the answer. In the case of X is 1 by 3, 3 into 1 by 3 is integer. But 1 by 3 is not an integer. So no is the answer. So am I getting unique answer from statement 2 alone? No. That means statement 2 alone is also not sufficient. Now the other option is both together. Both together. That is where you have to be careful, just like in the previous question. The example you are taking should be very clear. X by 3 not an integer, 3x not, 3x is an integer. Look at this example to save time. Look at this. If you take both the statements, if I am taking 2 by 3, x as 2, x as 2, 2 by 3, 1 second. No, this example. Okay, I'll take x equal to 1 itself. Now, x equal to 1 if you take 1 by 3 is not an integer, satisfied, but still x is an integer. So the answer is yes. But that same example I have to take for statement 2 when you are taking it together. Na? When you are taking it together. 3 into 1 is an integer is satisfied. Na? And 1 is an integer. So in both cases, yes, I am getting when you are taking two statements together. That means the example x equal to 1 is a valid example to get the answer yes. But now we have to search whether any other example can make the answer no, satisfying both the condition. Satisfying both the condition. What two conditions are satisfied? X by 3 should not be an integer. X by 3 should not be an integer means, for example, 2 by 3. If x is 2 by 3, 2 by 3 by 3 is what? 2 by 3 by 3 is what? 2 by 9. Na? It is not an integer. And x is an integer is no for that. Let us see whether the same 2 by 3 will work here. If I take x equal to 2 by 3 here, 3 into 2 by 3 is what? 3 and 3 cancels. It is an integer. That means x equal to 2 by 3 is a valid example for statement 1 and 2 to be satisfied. And for that valid example, the answer is no. That means it can be both yes and no. Na? That means that is not a unique solution. Yeah, definitely here this 2 by 3 example, you have to think in exam hall to get this example. That is really tricky. So don't worry too much if you think that it is difficult. I'm telling you facts actually. I don't want to give you false promise that all questions you can solve after the course. After the course, you will at least understand which question to solve, which questions to skip. In a cricket, those of you follow cricket, a good cricket batsman is not the batsman who can play all the balls. He is a batsman or she is a batsman who can understand which ball to try, which ball not to try. Na? Are you getting the point? Same thing is the case of UPSC. If you are preparing for an MBA, CAT or MAT, that is different. There are the number of questions you have to try. The number of questions you can skip is very less. But here the skippable question is almost half of the total questions. Na? 40 questions if you are targeting out of 80 questions. Out of every 2 questions, you can try 1 question and skip the other. So be optimistic. Don't worry too much if you are thinking like this question is too difficult. Yes, it will be. It will be. At least half of the question, if it is difficult also, still you can clear the cutoff. Still you can easily clear the cutoff if you are not selecting topics. Learn all chapters. Then only a seemingly difficult chapter, you may get very simple questions also. And seemingly simple chapters, you can get difficult questions also. So don't select chapters first. First learn all chapters. Did you understand this? Answer will be both statements are not sufficient, option D. Because if you use both statements, still the answer is not definite. It is yes or no. It can be both yes and no. So data sufficiency problem, remaining ones, please try as homework. Let us take non-data sufficiency problems. So try this question. Question number 2 in your worksheet. Question number 2. Yes. Question number. Okay. Sorry, it is not 2, na? Okay, sorry. Question 2 itself, please try. This is question 2. 2024, this was asked. After 2, you can try 3 also. 2, 3 and 7, please try. 2, 3, 7. Seven numbers such that distinct triplets. No, numbers, it is not necessary to be distinct. It can be same numbers also. 1 second, let me check. Yeah, numbers should be distinct because they have mentioned X, Y, Z. Na? So that is indirectly saying X, Y, Z are 3 different numbers. You are selecting. Na? Like you have a box of 7 numbers. From there you are selecting. So when you are taking a number, that number is not available in the box. Not only triplet, the numbers also should be distinct. So if you are taking 1, that 1 is missing in the box. Yeah. So you cannot, if you take X as 1, Y cannot be 1. That is what I'm saying. Because it's a selection. Yeah, it is not clearly mentioned X, Y, Z should be distinct. But as it is selected, you have to think that you have 7 numbers in front of you. You are picking up those numbers. So once you pick a number, that number is not available anymore. For the next triplet, you can use. For the same triplet, you cannot use again. Like if X is 1, Y cannot be 1. Any answers? B. X can be 1. Why X can't be 1? Because yeah, X cannot be 1. Correct. Because X is greater than multiple of 2, multiple of 3. Y, Z can be 1 or more. So yeah, X cannot be 1. That is true. Any answers? C. How many of you got A, B, C, D? Okay. So the number line idea can help you here. Question only say that you have to select the numbers from the first 7 natural number. 1, 2, 3, 4, 5, 6, 7 are the first 7 natural numbers. Huh? Such that X greater than 2Y greater than 3Z. So the size of the number, we are getting a comparison. If the first number is X, that should be greater than double of second number Y. Greater than, that means Y should be smaller than X for sure. Because double of Y is still less than X. X is greater than means still less than. Na? That means in number line, Y should be before X. Y should be before X. Y should be smaller means before X. Na? Left to right. And X is greater than 3Z also. Because X is greater than this and this is greater than this means X should be greater than 3Z also. X is greater than 3 times a number means X is definitely greater than the number. Na? So X is greater than Z. Or Z should be smaller than X. So Z should be before X also. Similarly, Z should be before Y also. Because 2 times a number. Again, there also practically think 2Y greater than 3Z means I am saying that the money that I have in my wallet, double of that is greater than triple of the money that you have in your wallet. So who have more money, me or you? Or A or B? If A have double the money of A is more than triple the money of B. Clearly, triple money is needed to make just double of this money. That means this money is much more than this. Na? That is why this money is 3 times is still smaller than double itself. Getting the comparison? So by that, what we can say? This Z should be smaller than Y. So in the number line, if I just roughly say Z should be before, Y should be before X. So X is largest. Did you understand that? Largest means let us start from the largest number. This is how to proceed with the question. So X, Y, Z. Tell me, largest number possible is 7. Na? So now we have something to start with. And z should be the smallest now. So let us start with z being 1. Z being 1. Now 7 greater than 3 times 1. Satisfied now. So what should be y? What all can be y? Can you take 2? Let us just take 2 and see. 2 times 2, 4. 3 times 1, 3. So 2y is greater than 3, so it is satisfied now. What about x greater than 2y? 7 greater than 2 times 2, 4. That is already satisfied. If this is satisfying, this will automatically be satisfied because we already compared these two. Are you getting? So this is a valid example, na? 7 to 1. Did you understand how we reached that example? So we started with x being the largest because x should be largest because x is greater than 2y also, x is greater than 3z also. That is why we started with the largest possible value. Now, this is one triplet, 7 to 1. Likewise, how many triplets are possible? That is the question. So let us skip 7 itself and y, z should be minimum, na? Z should be smallest, y middle, x largest. So 1 itself let us keep. Now the next possibility is you cannot take 2. Let us take the next value 3. If it is 3, what happens? 7 is more than 2 times 3 because 2 times 3 is 6 na. 7 is more than 6 na. So x greater than 2y is satisfied na. And 2y should be greater than 3z. 3z means 3 times 1, 3. 2y means what? 2 into 3, 6. 6 greater than 3 is satisfied na. So 7, 3, 1 is also a valid example. All of you clear? Now, if you keep 1 itself, the next possibility is 4. There's a problem in that possibility. Double of 4 should be less than 7. 7 is not greater than 8. Double of 4 is 8 now. 8 is not less than 7. So that possibility is not correct. So you cannot take this possibility. If 4 is not possible, means 5, 6, 7 not possible. Na? So there is no other possibility for y means this 7 starting case is impossible. So now 7 starting case is done. So x can be maximum 7. Maximum 7 means next possibility is 6. X should be biggest. So the next biggest number is 6 now. So take 6. So z should be minimum 1. Let us start from 1. So here if I take 2, that is the next smallest, next greater value. Na? 6 is 2 times y. 2 times 2, 4 is greater than 3 times 1. Satisfied? X greater than 2y. 2 times y is what? 2 into 2, 4. 6 is greater than 4. Na? So this condition is fully satisfied. So 6 to 1 is totally okay. Now what about 6? If you are taking 2 here, then you have to take minimum 3 here. Na? Are you getting? So if you get 3, what is the problem? 3 double is 6. 6 is not greater than 6. 6 is equal to 6. So it is not satisfying this. So this condition is not possible. So that means we reached all the possibility of 6. Only 6. Now there is one more possibility. For 5, if I take 5, it can be 1 here. So the minimum possibility is 2 here. Check this out. 2 times 2, 4 is greater than 3 times 1. 4 is greater than 3. So satisfying 2y greater than 3 set. X greater than 2y. 5 greater than 2 times 2. Satisfying that also. Na?